Now we can do the significance as an F-test also. And the F-calc is MSR, the mean square for regression, divided by MSE, the mean square of error. And then we can do a p-value test or an F-test. So let's go to the Excel file. So F is MSR divided by MSE. So we can go MSR. If we go back up where we calculated, okay, MSR and MSE, so MSR divided by MSE. So that will give us the F value. Now, of course, this F value is also available from our regression output. So if you go back to the data analysis regression output, you see the F here, and that is the same F like how we have calculated. Okay. Now we also need to note that F is simply T squared. So these two are kind of related. These are two different methods for the same thing. So just take a look at this. So you take the T and you square that T and you get the F value exactly. Okay, this is exactly the same number as that one. Okay, now the numerator degrees of freedom comes from MSR, so that is equal to, okay, we'll get it from here. Okay, and the denominator degrees of freedom is SSE degrees of freedom, which is over here. And these are also available from the data analysis regression output right here, 1 and 8. Okay. Now we can do the test using F table. So this is, so F table will be F dot INV dot RT, and the probability is alpha value, which is right there, and then the 2 degrees of freedoms, degrees of freedom for the numerator and the degrees of freedom for the denominator. So that will give us the T value, F table value, and since the F calculated value is greater than F table value, we reject the null hypothesis. Okay, there it is. And P value is F dot dist dot RT. Okay, now we use the F calc and then the 2 degrees of freedoms. So that will give us the P value. Okay, and you see that the P value is exactly same as what we got before. And then since our P value is less than alpha, we reject the null hypothesis. So that's our conclusion. So same interpretation like before. This is a different method. So we can, in simple regression, we can either use the T test or we can use the F test. Now let's look at developing a confidence interval for the slope coefficient. So this is the formula B sub 1 plus this is our margin of error, where we multiply the T table value with the standard error of the slope coefficient, and we have all this information already computed. So B sub 1 is from here, B sub 1, okay, and S sub B sub 1, so we have calculated that here in the T test, S sub B sub 1, okay, and suppose we want 95% confidence interval, okay, degrees of freedom, and that is degrees of freedom for MSE, which we have here again in the T test area. So T table value T sub alpha over 2 is T dot INV dot 2T. Okay, and the probability is the alpha value, which is 1 minus the confidence level. 1 minus confidence level will give us the alpha value, comma, degrees of freedom. So that will give us the T table value, and we multiply the T table value with the S sub B sub 1. That will give us the margin of error, and slope coefficient minus margin of error will give us the lower bound, and slope coefficient plus margin of error will give us the upper bound. So let's format these to say 3 decimal places. So now we have to interpret. So we can say that we are 95% confidence that B sub 1, remember B sub 1 is the increase in quarterly sales that we can expect for 1,000 student increase in the student population. So if student population increases by 1,000, the quarterly sales will go up by 3,662, between 3,662 and 6,338. So that's the interpretation for the confidence interval for slope coefficient.